Welcome back, and let's take a look at some quadratic exponential equations. So first of all, how can we identify whether an exponential equation is in quadratic form? So the way we know it is because one of the terms will have an exponent that is double of the exponent in the other term. So we're going to have two terms, that is two terms that are in exponential form, and one of the exponents will be double of the other. And here is an example. 5 to the power 2x minus 5 to the power x equals 20. So as you can see here, we have 1, 2, 3 terms. So two of the terms will have x in the exponent, and that's what makes this an exponential equation. Now, if you compare these two exponents, you see that, and the bases obviously are the same, but when you compare the exponents, you see one is double the other. So that's what we mean by saying that one of the exponents will be double the other. So how do we solve this? Well, we solve them as quadratic equations, obviously, because they are quadratic equations, and as exponential equations. So we're going to get started with taking the terms to the left, all the terms to one side of the equation, so in this case to the left side, because when solving quadratic equations or any equation of degree higher than 1, we want all terms to be to one side and just leave 0 on the other. Now, it is very easy for some people to look at this equation slightly differently. So what I'm trying to say in here is that we can change the way this equation looks by replacing the exponential terms. So this looks exactly like a quadratic, and we don't see the exponential. So we can deal with one thing at a time, right? So we can deal with them as quadratics first. So what we want to do is we're going to replace 5 to the power of x by some variable a. So we're going to write 5 to the power of x squared minus 5 to the power of x here, and then minus 20 equals 0, and we replace 5 to the power of x by some variable a. Now, this is totally optional, so we do not have to necessarily do this way. And I know that once you master quadratic exponential equations, you are going to want to drop this method because it is a little bit longer than the normal. But at this point, when we're trying to kind of make sense of how this process works, I would just keep the new, or what I call the helping variable here. Now, as you can see, now we have formed a quadratic equation that we are quite capable of solving. So we can use either quadratic formula or factoring. In this case, I would say that this is factorable, so which means that I'm going to try factoring first. So it's the simple trinomial because coefficient is 1, so we need to find two numbers that add to -1 and multiply to -20. And you've probably guessed them already. So we have -5 and +4. So they would add to a -1 and would multiply to a -20. Now we're going to solve the equation for coefficient a. So we'll say a -5 is 0 or a plus 4 equals 0. So from here, we get a equals 5 or a equals -4. Now, wait a second. So we are not trying to solve the equation for a. So our task was to solve the equation for x. So remember what the coefficient a represents, or the variable a represents. So it's 5 to the power of x. So we're going to bring back 5 to the x, make it equal to 5, or 5 to the power of x is equal to -4. So we're going to solve each separate equation. As you can see here, we have an equation similar to the first examples in this lesson. So bases are the same, only a single number or term in each side. So that means the exponents will be equal. And this is the exponent x. Here we see nothing, but we know when there is nothing, we can put a 1. So that tells us that x is equal to 1. On the other hand, for this equation, we're going to say there is no solution because we know that a positive base to any power will never give a negative value. So we're going to say we get no solutions from here. And here we go. We're ready to state our final answer. We're going to say that x equals 1. So in the next example, I made up a question very similar to what we just did. And on the side in here, you have all the steps. You can go through them on your own. If you ever get stuck when you practice at home, always look at the steps. Do not give up and practice as much as you can, because the more you practice, the faster you become at thinking, and that's what math is about, right? So think faster, and also obviously try to understand the different ways and the connections that exist between the variables and the information given. So long story short, example 6. So we have 3 to the power 2x minus 5, 3 to the power x equals negative 6. So when I look at this equation, I see 1, 2, 3 terms. And another thing I notice here is that I have two exponential terms with variable in the exponent, and they are subtracted. There is no rule that allows me to subtract two exponential numbers. So the next thing that I notice is that the bases in both exponential terms are the same. So the base is 3. And one of the exponents is x, and the other exponent is 2x. So I'm going to say that in this case, we have 3 to the power of x and then squared. And next we have minus 5 times 3 to the power of x. And then we're going to bring negative 6 to the left side to make it positive. And obviously we want to do this because it's a quadratic equation. As we mentioned, quadratic equations are solved by bringing first all the terms to one side, right? So you can bring the helping variable n. So that means that we have a squared minus 5a, and then plus 6, that's the bell. And I'm going to finish this very quickly, and we're going to factor. And we have a minus 3, a minus 2, from where we derive that a would be 3 or positive 2. And from here on, we bring 3 to the power of x in. So 3 to the power of x equals 1, or 3 to the power of x is equal to 2. So that means that either x equals 1 in this case, or, and for this one here, we solve it by using the special method that I explained in a separate video. So in order to find the value of the exponent here when the bases are different, then we're going to say x is, which means equals, the exponent, or another word we use for exponent is the word log, to which we raise the base 3 in order to obtain the number 2. And the way that you find this on the calculator is by simply splitting the numbers 2 and 3 and sticking a log to it. And in this case, this would be the exact answer. And the approximate answer is found by simply using the calculator, which I am going to right now. And we're going to have log of 2 divided by log of 3. And the answer is x equals 0.63. And we want to round the answer to 2 decimals because logs are exponents, and exponents are powerful or can change the value of a term powerfully. And I hope these instructions were useful and helpful. Please continue with the practice questions, and if you have any questions, please ask me in class. Have a nice day. Thank you for learning with me. Bye for now.